We now have a nice spec for namespace registry, which ends up being uh, relevant here, just because in terms of all our mechanics, we have to, when you launch contracts, you have to know um, where everything is registered. So I was hoping Mike was going to get a walk through that, but I might have him. Well, we can do that next week if he's not going to show up. Also, we went through with Michael Birch and reviewed his article. I don't know if you guys had a chance to review the article. And Michael has a very nice visualization now to go with his simulation. So maybe I'll try to get him to do that here. I don't know if you saw the community hangout, Danny, but we demoed community hangout.
Oh, cool.
Yeah.
I did not see that. I poked around his code a little bit last week, and I have not dug into his write-up as I should.
No worries, no worries. Everybody's busy doing their stuff, I'm sure, but and then I am working right now more on the research side with I want to try to push a bit on the trace monoidal the partial trace construction. See if I can push that through over the next couple of weeks, so I can we can talk about how the partiality lines up with the Byzantine faults. So that's kind of what I've been doing. There's a really nice book that talks about a wide range of trace monoidal categories called Picturing Quantum Processes. It's by a friend of mine now, Bob Kuka, and his colleague Alex Kissinger. So if you guys are ever interested in that, they developed the whole formalism from the ground up, just using string diagrams. So it's a lot easier. I think for some people it's easier to use the diagrams than it is to use the equations. So if you guys are interested in looking at,
I just put the link up for the book. I'll check it out.
yeah, it's good. All right, that's our update. Unless Mike shows up.
Vlad is showing up right now, and Nate just showed up.
Sweet.
Hey guys, sorry I'm late.
No worries.
Good. Danny, have you given an update yet?
No, I haven't.
Okay, cool.
A lot of various things going on. We there's now instead of just a binary consensus in their protocol in the repo, there's an integer consensus, which we realized the binary consensus is actually just a special case of the integer consensus, at least as the integer consensus was written, and can use most of the same bones and stuff. So that's pretty cool. And a lot of cleanup, a lot of, I don't know, what do you say, Nate? Where are we at?
General improvements. You did some really cool work on like making the Genesis message a reasonable thing. And I'd say the repo is getting to a place where it's like, consumable by a human being, which is cool and kind of unique in the history of CBC Casper's repo. So that's fun. But yeah, cool. I can jump into a update as well if you're done, Danny. By the way, hi Vlad. Yeah. Cool. So yeah, clean up with Danny. Did some work on integer consensus. Also started working on what I'm calling like the minimal fork choice. So Vlad and I spent some time over the weekend working on kind of just like two algorithms. So I guess maybe let me give motivation for the minimal fork choice. Right. So as of now, we have like this greedy fork choice rule where we started our last finalized block and we kind of walk our way down the tree, making decisions when we have to, picking the max weight subtree, right? It's like just this classic ghost fork choice rule. But what we kind of want to do is kind of want to make it so it's as efficient as possible. And so we only have to make decisions when we need to. So you can kind of imagine like, there's a bunch of nodes in the tree that we walk down that are just like a huge waste of space and don't actually need to be there. And so what we can do is we can kind of like, create like a reduced version of the tree that kind of makes it much more, hypothetically makes it much more efficient to walk down. So that's what the reduced fork choice tree is, and that's why we want to do it. And so Vlad and I came up with an algorithm that kind of, there's two algorithms. The first one is something that takes like a full fork choice tree, I'll call it, and you run the algorithm on it, and it returns the reduced tree. That's the first thing. Then the second thing is like something that maintains this tree over time as you continue to receive messages, and hypothetically does that in an efficient way. So yeah, we came up with like the first like kind of rough spec for those. I implemented the reduce one, and it's working, which is pretty cool. And now the fork choice tree is like super small, but I haven't finished implementing the sequential run. There's a couple bugs hanging about that I have to fix. But anyways, yeah, started work there. It's kind of just like low hanging fruit and an efficiency gain, and it's kind of fun.
Cool.
Yeah, if people want, we can talk about it a bit. It's kind of interesting. I don't know if that would be cool, but
Yeah, sure.
Cool. So the general idea is like, okay, so let's assume we have some like tree. So by the way, let me say another cool thing about this like minimal fork choice tree. Is like we can bound like the computational complexity of the fork choice. Like the number of decisions you will have to make will be at most like n-1, where n is the number of validators. So it like kind of helps us get a handle on the amount of complexity that can exist. But pretty much here's how it works. So let's say we have some minimal tree, and it has three types of nodes. Okay, so the first node is it has the last finalized message. We keep that in there for ease. The second thing it has what we've been calling stressed parents or stressed ancestors. Okay, and stressed parents or stressed ancestors are pretty much any node where you have a decision, right? And this means you can go one way and end up on one latest message, or you can go another way and end up on another latest message. And then the last thing that we store for ease is latest messages, even though you might not necessarily need them all the time. It kind of makes things easier. So those are the three types of nodes that exist in our minimal fork choice tree. And now let's say we want to insert a new node. So what we do is we follow this new node's estimate back until we find some estimate that's in the tree. So pretty much what we do is we find its youngest ancestor that's currently in the tree, okay? And we call that the root, which maybe isn't a great name. But then what we do is we look through the children of the root in this minimal tree, okay? And we pretty much say, what's the common ancestor? What is the youngest common ancestor between this new block and these children of the root of the new block? Okay, and if that common ancestor isn't, if it isn't the root, then we know that these two messages share some common ancestor in the way, share some common ancestor, and so we have to insert kind of an intermediate node. But if they don't share, and if none of these messages do share a common ancestor other than the root, then we know that this message is just built off the root, and so we add it off the root, and that's pretty much the general idea. It might have been a little fast and kind of like blew through it, but there's a rough spec I typed up that I will post in the chat right now as well. So feel free to check it out and hit me up. It's obviously it's a first draft, but it exists. So anyways, there it is.
Sweet. Yeah, I'm gonna review that issue today. Vlad, you there?
Looks like
He,
Mike. Oh, Vlad's here too. Yeah.
he unmuted himself, but Vlad, we can't hear you. BT Dubs.
Your mic is unmuted, Vlad, but we can't hear you. Zoom's kind of weird on Linux if you use Linux.
Yeah. Yeah, it is. Well, maybe Mike can go if he wants to go.
Yeah, sure.
Cool. This is only tangentially related to the direct line, but it's important when we're talking about our stuff.
So this is a document we drew up as a proposal for how to include URLs and more generally URIs in as names in Relay. Hold on, I'm going to shut my door just a sec. So in row calculus, names are quoted processes. We would like to keep this @p notation or something similar to it, having to encode in the source code a process as a URN just makes the whole thing unreadable. But we would also like to be able to use URIs as names. So I propose this backtick notation. In the URI format, you have to %escape lots of different stuff, including backticks. So it's very clear where the URI ends. So this would be the equivalent of @p. It's a name. Here it's saying, I want to establish an HTTP session with this server. So I send it a return channel to use and then listen on the return channel for the send and receive channels in the session, just as an example. URLs are a special kind of URI. They've got this schema out front, and there are well-known protocols on how to resolve URLs and interact with the servers and the protocols that go with them, etc. So those are just going to work the way we'd expect them to, something like this. A URN, however, is just for naming a resource. It doesn't say anything about how to locate it. So in Erlang, I'm proposing that all URNs be straight up Erlang names and are only used internally. The IANA maintains a list of organizations that manage specific URN namespaces. You can see here, all these different things which have a corresponding RFC and get approved. And there's some organization that manages them, like ISSN or ISBN. So I'm proposing that we manage, or at least the Erlang co-op manages the Erlang URN namespace. So things that begin with URN : Erlang : the way that namespaces has been used in the Erlang documentation and speaking about Erlang is that a namespace is an expression in some language that denotes a set of names. So in Erlang's type system, we have things like top and bottom or true and false, intersection and union or and or, set negation, implication exists for all, and so on, and some expressions for denoting Java built-ins we're just going to keep that language itself. But for describing URNs, I'm proposing that the Erlang namespace, the Erlang URN namespace, have this format: an identity followed by a / delimited path. And I'll get down to what identity means here below, but that's the idea. And so we can use express style path expressions, which is really just a variant on regular expressions. Express style path expressions just have some built-in things that make naming groups easier. So for example, this colon here means this is a named group, and the default pattern that the named group captures is everything but /. So it's really just another regular expression language or an extension of it, because you can put a different grouping pattern after service ID in parentheses, for instance, and have it capture that instead. So this is a common language used in the Node.js community. And apparently on some other servers, though I'm not aware of which ones. Right, so then my proposal is that URNs in the URN Erlang namespace be aliases for other private names. In Erlang, we need the ability to create private names in order to have any hope of using object capability principles. It's somewhat like in Java, even though the underlying implementation uses pointers or integers representing memory locations, there's no way to turn an integer into an object reference in Java. And so similarly on Erlang, we have a new operator that is implemented underneath as public names because they're on the blockchain, everybody can see them. But you can't actually mention them in the source code and get hold of these private names. So it's the private names will be in a namespace separate from URNs and from quoted processes. This example here shows what I mean by aliasing. This is a dynamic registration of this pattern. So it says we get a new input-output I/O pair. The idea of an I/O pair is that you can either think of it as implicitly creating a forwarder where it listens on the output channel and sends on the input channel, but everything else can only listen on input and send on output. So if you have a process that is sending on output, or sending on this thing, it will forward to sending on output. This is an alias for sending on this output channel. And then when you listen on input, you're the only one that can receive messages. If anyone else tries to listen on output or listen on this public thing, it'll say that's a type error. This way of setting things up allows the input channel to be private to the contract in which this I/O pair is created. Another way of implementing that rather than a forwarder is adjusting the notion of name equivalence so that sending on output and receiving on input, the virtual machine recognizes those two as connecting to each other. And
awesome. Yeah, this is awesome. I'm super happy you're doing this at the virtual machine layer. I mean, I totally feel like that's the obvious and only really solution.
So once this thing is set up, thanks, Vlad. this is a dynamic use of the registry. The registry itself will be a privileged Erlang contract, like the Rev wallet. It'll exist on all nodes. Contract deployment is a static use of the registry. You interact with your client the client interacts with the node, and as part of the deployment process does this registration of the contract at a particular URN. So then I said I was going to get to identity. My proposal is that for the first, say, 5 years, identities are strictly domain names, and you can prove ownership of a domain name in any of the usual ways. This thing links to a Google Doc that says, like, you upload a particular file, or you get, provide your information through DNS, or an HTML tag like a meta in the source, for various ways of confirming ownership of a domain. After that, we open this up to arbitrary alphanumeric strings, and then it's first come, first serve.
Sorry, question. Not sure I follow. So to register a contract, you need a domain name to create a contract?
I guess we would need a different set of ways of doing that for a contract. Greg, do you have any ideas on that?
I mean, you can use a domain name, but do you need one? Yeah, you're going to need one, I think.
Well, in this proposal, you would. I'm open to other ideas.
So I'm definitely not by any means an expert. But what I would say is, as someone who got into this space because they wanted to write smart contracts, that seems like an unusually high barrier to entry, which is maybe a good thing. That's not the worst thing in the world. Maybe it's too easy, but that seems like,
I guess a UUID would work just as well.
Yeah, this is Rick. Can you guys hear me?
Yes.
I was just going to say that you should probably generate a domain name from UUIDs for free or automatically. Because sorry to jump in late. Are the contracts, they're not mutable at all, right? So once you publish to that address, it's the content is fixed, right?
Right.
Yep.
Yeah. So you could just use a hash or something as a like content addressable. You are I don't remember which one it is.
This would be a URN.
Yeah. So you could just generate one, and then if the user wishes, they could generate, the named one.
That seems reasonable. That this part would either be the hash of the contract you're publishing or a domain name.
Mm-hmm.
Sounds fine.
Yeah, that seems better. Just because, I definitely didn't have a domain name when I first started, trying to get into stuff.
Well, but you'd also have your own name service running in RChain, right? That would be bridging between the RChain namespace and the internet TLD namespace, right?
Oh, absolutely. Yeah. Yeah. So the thing is with a domain name that is used in any of the other protocols, right? HTTP or whatever. There you're using the URI that specifies as the protocol and the domain name to interact with, as I wrote up here. So nobody's going to be able to register google.com for use with HTTP. If Google chooses not to register their thing in the Erlang namespace after 5 years, then whatever. Yeah, we'll deal with that later.
Yeah, that's also like what foundations are for, you know? I mean, that's why
Right.
you guys have a
Yeah.
foundation to resolve those issues.
Thank you, Mike. I really appreciate that. Because sometimes these nuts and bolts things are really important here.
Do we need an extra bit here in the URN to say whether it's a domain or a hash?
Oh,
I mean, the dot, if it doesn't have a TLD at the end, then it can't be a domain. But that's kind of an ad hoc, that's content sniffing, which is evil.
yeah.
Yeah, I think the bit is fine. The other idea is like you can just have a different format, but that's probably less good.
Yeah, I think I'll add one more chunk here that will say the format type.
Yeah.
So, yeah. The thing about using the slash delimited part here is that part of the semantics of express routing are that the most specific path wins. So there will be not only, I mean, this registry will be a routing table more than just an association of channel to path here.
Yeah.
So there will have to be some semantics about the registry that get defined. But that's the basic idea. I think I'll go in there and edit that chunk in now.
Cool. Was there more here, or should we?
Nope, that was it.
Cool. Who was there other? Were there other updates?
Not for me, thanks.
I have updates.
All right, let's hear them.
Sweet. Well, it's been a couple weeks, I think. So I managed to make it to the stand-up. So I have a bunch of updates. I guess the main one that I want to talk about is this kind of sharding solution. I have this like basically a cross-shard atomicity solution that fits into my safety proof and like the correct construction because this protocol stuff.
Yay.
And it's using the fork choice rule that we actually talked about in Park City, Greg. Basically, there's there's like more to provide the atomicity across shards.
Okay. Yeah.
So basically, the way the fork choice rule works is like there's some root shard and there's a bunch of other shards, and then the root basically is going to be like it's we'll call it the root blockchain actually, and you do a fork choice rule there. You say like ghost, and you and then you'll use that fork choice rule to kind of restrict and inform the fork choice rules to different shards. Specifically, the blocks on the root shard can also be tuples of blocks, namely blocks of the form, a block on the root shard, and then a block on shard I, a block on shard J, a block on shard K, etc. So you have like an n tuple potentially. But let's just think about doubles where I have the block on the root shard and another block, and a triple where I have a block on root shard and then like two other blocks on two shards. Basically, so when you do the fork choice rule on the root, it's the same as a normal ghost rule, right? You just look at the latest messages and follow the weight. But to start a fork choice rule on shard I, you have to start from the block referenced to by the latest block in the root shard, which has a block from shard I in it in this like kind of tuple form. And then so you just start the block. You start the fork choice rule there. So the fork choice rule on the shards are kind of like somehow, only exist kind of like after they are like like using kind of effectively using a last finalized block, even though it's not really finalized, of the that was included in the root chain. So say basically like somehow the fork choices on the shards are kind of in some way refinements of the fork choice in the root. And so does that sound like it makes sense? Like sounds like reasonable?
Look, can you?
Here's a way to picture it, right? All of the fork choice rules on any shard looks like choosing between branches of a tree. Imagine you have a map from like you have like the root shard, and then there's arrows from certain root shard blocks to certain blocks on the shards. And on the shards, you only do the fork choice rule in the tree that starts with the root at that block from the latest block that was included in the fork choice rule in the root. So, for example, if the last block on the fork choice on the root has a block from shard I, then like the fork choice rule from shard I will start at that block.
So I have a lot of questions. I think I get it, but who's actually, so when you make a shard, where are the validators for the shard specified?
Yeah, I mean, there's no such thing. I mean, that's you're asking about like later stage questions, this iteration like one of the thing.
Okay. Well, then in that case, then my other question is, it seems like these, when you validate a shard, since the root, since shard 0 doesn't know necessarily. I mean, it seems like you're going to be changing the size of your blocks. Like it seems like your block size is going to be highly variable based on the variance of the rates of change on the shards, right?
No, I'm so like all my blocks are empty in some way, right? I mean, I might get more or less blocks. So, but, I hear you, but also like I would say like questions that are like like second order questions, not like all I'm really going to talk about and address is kind of like safety and like safety of cross shard atomic, and how to do like a cross shard atomic thing.
Yeah,
These are kind of dots and liveness.
Yeah, you're abstracting away on the payload part.
There's like I start off with the basic thing that's required for safety, and then like we make it really efficient, and we think about rate limiting and all that other stuff, like in an iteration. Just as like basically because like this is all kind of new turf, and we got to like take things one step at a time. But basically like the even looking at the fork choice rule is interesting, right? There's all sorts of other stuff that matters, but like all I'm really talking about is the fork choice rule of the sharding system.
Yeah, I think that makes sense, Ben. I think it's good, but obviously all my questions are at these other layers.
Yeah, and I'm and I think I could provide answers to them, but I don't really want to go into it right now.
Yep, makes sense.
Okay, so basically, like we have a fork choice rule at the root level, and then each of the shards kind of continue it based on the last place at which the root pointed to. And basically, okay, well, safety means the same thing as before. Basically, a block is safe if it's going to be in the best blockchain forever, right? If it's going to be in the fork choice rule forever, and that's kind of a thing that's defined on a global basis, right? You can think about the fork choice rule we just did, right? We just said how to do it on a shard, even though as any validator we wouldn't necessarily want to do it on a shard, but we can understand what safety means. Basically, that like it will always be in the blockchain in the fork choice rule on some shard. Because every block is on some shard. So we have the same safety definition as usual. The same like common features thing, basically the same setup for the consensus protocol safety. And then the neat thing, the thing that's like exciting and fun, is the cross-shard atomicity. And basically the way that works is with these blocks that have this triple. So like remember this triple block emerge where we have like a base block from the base from the root chain, and then like a block from shard I, and then a block from shard K. Or let's say shard J actually. So like the basically what's going to happen is this block from shard I in that tuple is going to be executed. It's going to be part of the fork choice rule in shard I, and the block on shard J in that tuple is going to be part of the fork choice rule in shard J. And so basically that block, that triple, is really a block on each three of these shards, and it's executed as like the first one on the root, and then the second one on the ith shard, and the third one on the jth shards. So basically, if the block is in the root, then it will be on all of on both of those shards. So that's kind of like one kind of piece, one side of the atomicity, right? The other side is like that if it's like not there, then those blocks, that block like should be in the fork choice rule of any of these shards. And basically, I basically achieve that by giving that block a negative fork choice rule, a negative score, if it's not in the root choice, in the choice on the root. And so basically, like if it is in the root, then it's in both shards fork choice. If it's not in the root, then it's in neither, because it would need to be in the root.
The tuples specifically, right?
Yeah, the tuple is the block we're talking about. Yeah.
Okay.
So so the idea here is like, for example, like you can have a transaction spanning from shard I to shard J in this thing, and basically like it would have to just like basically either be rejected or have to show up in the root shard. And like if it's in the root shard, then everyone is kind of forced to, the shards are like forced to start their fork choice rule there or later. And so unless there's a reversion in the root shard, it won't be reverted. And if there's a reversion of the root shard, that's really normal, unless it's safe, in which case it represents a consensus failure, quite likely or potentially. And so we basically have like a very normal consensus shenanigans going on with kind of sharding, and basically the same, like safety is still the same, right? If somehow like the fork choice rule hasn't changed since the last time I talked about safety at all, right? Except it has changed. It has a little bit. I did change it to give the negative score to these blocks. Not in the root chart, not in the root shade. And so basically, like it's kind of neat because it's really simple protocol, and it has the kinds of properties that make it relatively easy to implement, I'd say. What do you guys think?
I'm just trying to construct a counterexample.
For the atomicity.
Yeah, where you've got interference because you've got transactions spanning two different shards.
Yeah, all transactions that go across shards have to be in the root shard.
Or the first
to.
common shard between them, because it's hierarchical, right?
Yeah, you're getting a little step ahead of yourself, but yes, that's where we're going. You gotta yes.
Yeah, least common shard is the way we do it in our chain.
Least common. Okay.
The one that contains.
I get it. I get it. Yeah, really. Yeah. So that's basically that's kind of the story. Where basically like if it's not posted there, then you don't get the atomicity in this way. And the nice thing about this atomicity is it's not like an eventual kind of thing. It's like a property of the fork choice.
Yeah, it seems like it would be safe to me. Like I'm glad that you're putting safety first, but your actual like execution guarantees, my intuition tells me they're going to be quite weird, potentially.
Yeah. I mean, I think it's going to be badass as hell, Rick.
I'm not disagreeing with that. I'm not disagreeing with that at all. But I think if, well, I guess it depends on what your contract call model is, right? If you have this sort of
Oh yeah. So I'm not even there yet. Yeah, I haven't even gotten there. I mean, that is actually, you're right. So as soon as you get talking about that, it gets more complicated. Basically, the only thing I really have right now is like waiting. We basically need to either only allow contracts to call cross shard when they happen to be called in these blocks, or we have queues and things waiting to call those blocks.
I mean, I think it's just, you just have to specify in advance so that you can schedule the, so that you can actually schedule what to do. I think the issue, I mean, it's the same issue that in general, where Ethereum has this sort of unbound, underspecified calling conventions, and it gives you all this sort of problems, but we don't, I mean, we don't have those problems, so we just don't do that. We just actually say within the shard, the shard should specify what contracts outside the shard can be called, and then there should be a function that allows you to add or remove those contracts.
I don't know. I don't really agree. I mean, I would rather have atomicity and like sorry, not atomicity, like shard, like opacity or transparency, depending on how you think about it, and it's like routing of the queuing and routing of cross shard calls to wherever they need to go.
But then I can construct contracts that are like brutal on the, like I can guarantee a worst time possible performance contract. And what's going to stop writing that?
You have to pay for it. That's at the end of the day, like that's what will stop it.
Yeah. Well, the problem is if you're charging everyone, if you're charging the good actors the stopping the bad actor price because you let the bad actors construct arbitrarily bad contracts, your contract's going to be needlessly expensive.
I mean, welcome to Ethereum,
Well, but again, that's what I'm saying. I mean, I'm totally welcome with having that discussion and saying, well, that's the trade-off that we're making. But I feel like most people in the world don't want to make that trade-off.
I mean, I hear you, but somehow I feel like I feel I don't know. I feel like it's not really likely to really change. I mean, I don't know. I guess at some level we should just think about what if we just had an abstract rewrite system with like an arbitrary kind of semantics, and think about what it would take to make a like sharded system for that, right?
Yeah, I think that makes sense from a process perspective. I guess I'm really jumping the gun here, but I think that you'll find that you'll either have a depth limit to the depth of shards, so that you have finality guarantees, or you'll restrict how far across this whole tree a contract call can really go.
Yeah, I mean, basically, like that's kind of the idea. I mean, basically, but the way to do it right now, we're thinking is like gas limit, but also like load balancing does do some work to help, like make sure that like you're not in the worst case too often.
Yeah, but that's the issue, right? I mean, again, the load balancing assumes non-adversarial shards.
No, it deals with adversarial shards by like balancing the loads instead of allowing like one shard to become like overweight.
Oh no, but I mean, okay, well, we're talking about two different things. So you can rate limit the adversarial shard, but the adversarial shard will still be making the most complicated calls possible just to make the most complicated calls possible.
Yeah, but I mean, they pay for it, and there are limits, gas limits.
Yeah, I think that, well, I mean, remember that gas is this bin filling problem, and it's basically like intractable. So the issue with using,
I mean, there's totally good enough. I mean, there's such thing as good enough.
yeah, I mean, yes and no. I mean, again, I think it's hard for us to say. I mean, we don't know what good enough is because we don't have the information to even say that. But yes, I agree that good enough does exist.
Well, good enough for known DOS attacks. We're pretty much good enough for known DOS attacks right now. Some way, right?
Yeah. And I am thinking about like every, I do have a tendency to enumerate every attack I can think of without worrying about the likelihood. So yeah, I mean, it does sound good. And I think that your sort of answer to constraint is good. And also, I mean, in the R-chain community, I mean, there is a willingness to do this sort of, I have much more faith that you'll implement the correct algorithm. So that's sort of like a strong counter to my argument, because I mean, in most environments, the algorithm that you just described, Vlad, is really complicated, and I'd be like, well, who's going to implement it? But I mean, here it's like, okay, well, you guys will implement it.
I mean, I think like, I mean, I think we could probably implement it in like a week. Danny, Nate, what do you think? The safety oracle is pretty much the same also.
So for the safety oracle, do you have to check the safety of the block above?
Check the root safety.
Yeah. Yeah.
First, because if the root's not safe from where you're starting your fork choice rule, then nothing on that shard is safe.
Yeah, actually, I think
if it is safe, then you just run the safety rule there, and it's and what all the blocks that are safe there are also safe.
So is it? I guess you don't even have to run a safety oracle on your shard ever.
No, you do if it's safe on the parent shard. You have a bunch of blocks on top of the last time you were pointed to by the root.
But those might get reverted by the root shard.
Only if they actually point to the root shard. If they're just
do they have to point to the root shard as well?
Yeah, no, only if they're doing outgoing transactions, right? Only if
interesting. Okay, cool.
Only internal transactions, and they can finalize blocks and not have an issue.
Okay, cool. I get you. Yeah. It doesn't seem like a huge. The safety oracle doesn't seem like it'd have to change much at all, if at all.
And yeah, and basically for the estimate, we just have, instead of just like one blockchain, we just have like a root blockchain and a bunch of shard blockchains.
I think it's something we could simulate reasonably easily, but the like modeling a realistic usage of it would be the hard part. Like modeling like a real network, or modeling like interesting cases in it would be the more challenging, more interesting part of the project, probably.
Yeah, but
kind of a very toy situation right now.
Who needs to do that, right?
This would be a cool use of the testing lang if we can expand it.
Yeah, absolutely.
To specify.
Yeah, I feel like you could easily do that, right?
Yeah, for sure.
Or like
maybe not easily, but yeah, yeah.
Capital letters for the root shard, and then like a little like some kind of markup for an index for shard you're going to, and then lowercase letters. Or maybe you don't even need different cases. You just have a little like marker that says like, "Oh, now I'm going to the."
Yeah, I need to think about it. Nate and I were probably gonna have a conversation today about making the language more generic and maybe more usable across protocols. So we'll think about
that's cool.
how this might fit in.
That makes sense.
Yeah.
The language only works for the blockchain right now?
Yeah, because it has things like things that like maybe shouldn't be the core language, because it like came out as a testing language, and it's pretty much like the design is very heavily inspired by Casper FFG. Like it has things like assert, this validator's fork choice is this block.
Right.
Whereas the core should just be about like making and sending messages, and then you should maybe be able to extend the language per protocol if you have some specific things you want to do in that protocol.
Yeah, I mean, basically, unless the protocol has some kind of non-determinism in it, all you really would want to do is like send messages.
Yeah.
Make messages. Yeah, so I mean, so I'm pretty excited about the four choice rule thing because yeah, like Rick said, I mean, I'm pretty sure we can make this hierarchical, and then and I think it's kind of like I think like once you get safety down, um, you know, it's kind of you have a foundation to like start working on the other problems.
Vlad, I have a question.
Sure.
Okay, so you said like, we have to run, so like we're running the safety oracle to figure out if we're safe on some block on a shard. So first we have to run the safety oracle on like the last thing. Okay, so let's say we're like running this safety oracle for some block on the shard that's like, we're calling it like I+2, where I is a block that's been included in the main shard. It's like one of these triples or tuples or whatever, right? And so the first thing we have to do, right, is we have to run the safety oracle on this tuple block in the main shard, right?
Mm-hmm.
And then you said we have to run the safety oracle on the shard with like that valid.
If that oracle turns out to return like true, right?
If the first oracle call does.
Yeah.
Sure.
Then all the blocks that you have later than that are safe are also safe.
Yeah, but well, okay, but no. Well, what happens if then the root shard then adds another thing that's like a branch off of I that makes this atomic call?
How yeah, and how would it do that? Oh yeah, right. I did kind of. So so basically the idea is that it would do it at I+1, right?
Yeah.
And basically there's like this thing I kind of didn't mention that is necessary that is necessary to prevent this, which is basically like you have to. So it's one thing to make a tuple block, and it's another just to make a block that's made on a shard, like viewed by the root shard. So it's like if you post, for example, a justification into the root shard, then all of a sudden that's no longer a thing, right? So like basically what I'm saying is we can restrict the root shard to have a fork choice rule, and to have to make the new two block on the fork choice rule in as far as the fork choice on the lower shard has been committed to the higher shard, to the root shard. So basically imagine you like commit into the root shard justifications from the lower shard, then all of a sudden, whatever the like a valid block would have to be justified with respect to those, those views, right? Make sense? And it is more overhead, and it does kind of suck, but otherwise, basically, the shards don't get to finalize any blocks, and that sucks too. That sucks worse, actually. Because these like tuple blocks are harder to do than this thing of just committing justifications into the root chart.
Okay, sorry, but I think I follow. But what happens when there's just like a single validator, Zurich, a single validator who just like pretends to not see any anything past I, and then tries to get an atomic thing included, or sorry, are you saying like the justifications are included in the root shard, and then like all validators, any block that's then going to be included in any like tuple or triple in the main shard has to like at least have that justification?
Exactly. Yeah.
Oh, okay, that makes sense. Okay, I see you. Oh, okay, that's interesting. All right, cool.
Yeah, I mean, it's gonna be interesting to see if this thing is reasonable, and I think it will be. I mean, I feel like it's kind of simple, and I mean, the fork choice rule. I think actually like this is probably the thing that makes me the most concerned about the overhead is committing these justifications to the root and what that means. But I think basically like I basically keep my feeling is that only nodes who want to make two blocks that actually have those shards need to actually understand those justifications.
Oh, that's okay. And then other nodes just like say, oh, there's a bunch of extra data. I hope that's right. Whatever.
That's one thought. Yeah. The other thought is basically that like everyone needs to verify the fork choice rule on every shard whenever there's like a end block. So like whenever there's a cross shard block, like everyone who's running the protocol has to verify the fork choice rules on the shards.
Eve.
Right, because you can't really check if the block is valid otherwise, right?
Isn't part of the benefit of sharding like validators only having to or care about certain subsets of the chain?
Yeah, exactly. Yep. And so that's why that kind of sucks.
But it wouldn't necessarily be,
It's still probably an improvement, I think, because there's still some amount of. I mean, you could do potentially large amounts of concurrency before ever having a cross shard block.
I know this is more implementation, but I kind of touched on it in one of my original questions on Skype. But like, if I'm, who's going to be proposed? Like, if we're organizing validators into like shards and things, who's proposing tuples or triples?
The root shard validators is like the way I have it currently set up.
Is there any
that is
overlap?
something I would love to think about. No.
Yeah, let's say no. Let's say no. Cool stuff.
If there was overlap, and say a validator from shard I was the only validator who, right? Oh, there you go. That actually is great. So imagine we have the root shard be made of like a couple of delegates from every shard. I mean, I say delegates, but I don't mean delegates. A couple of validators sampled from every shard. Then they would basically be the ones that are responsible for making end blocks out of that shard, maybe. And maybe we put valid. There we go. Oh man, oh shit. So like imagine this. Every validator. So imagine like the every validator is at least in 2 shards. Let's say every validator is in 2 shards, and sometimes validators are also on the root. And if you are in 2 shards and the root, then you can make a block that is in each of them, and you can be held to account to your fork choice rules in each of them.
Yeah, just to let you know, guys, we've got a meeting at 8 in this room.
What I could do is end the broadcast. You guys can continue talking until Sergey and Misha come in here, if you want, or we can split until next week.
Yeah, we can do that. We might talk on our own outside.
Cool. Sorry for the. Usually, we run over and that's fine, but this week we have to cut here, so that's okay with you guys.
Yeah, no worries.
Cool. All right. Well, I'm just gonna stop, and you guys can continue for a few more minutes till they come in here.